parabolas you have seen before. I don't believe you had seen circles or ellipses or hyperbolas before. Those were all new to you. Parabolas is something you have seen before. I know for sure that you have seen things that just look like y equals ax squared plus bx plus c. You've seen them in factored form. I think you've probably done vertex form, but that I'm a little less sure of. You've definitely seen just graphing regular parabolas, because it's basically like half of Math 2. So, and you do it some in Math 1 and some more in Math 3. So parabolas are covered pretty heavily. What I don't know if you've seen are sideways parabolas. Have you guys seen sideways parabolas before? So this is where we're going to differ. So notice the difference here. Whereas what we normally see, we got y equals and we have an x squared. If we switch our x and y's in that, it's going to give us a parabola that ends up on its side. So you'll have, if you have x equals and then you have a y squared, you get a parabola that ends up on its side. So that's what's going to be the big difference that we're going to look at. I actually think parabolas are possibly a little more difficult than ellipses and hyperbolas and whatnot, even though you have seen them before, and mostly because of this fact that they can be turned on their side, like this. So parabolas are a lot different than ellipses and circles and hyperbolas, because in the other three, your x is squared and your y is squared. For these, you're only going to have one of the variables squared, either the x or the y, not both. We will see that we have, if we have a parabola that opens upwards or downwards, it is our typical y equals x squared. In vertex form, it is going to look like this: y equals a times x minus h squared plus k. I usually do not do this section before we do transformations of functions, where we move functions like up and down and left and right and flip them over. But if I add a number out here on the end, that moves the function up or down. If I want to move it left or right, I'll add or subtract a number here. It goes the opposite direction. So if you have a minus h, it would be actually to the right. H, it goes the opposite direction of that sign that you see there. With a parabola, there are several different things that we have to know. This P equals 1 over 4a, that is called your focal length. And it is the distance from your parabola to your focus. The focus for a parabola is going to be somewhere on the inside of the parabola. If it opens left and right, it would be here. And then, so your vertex is going to be HK, the opposite of the sign here, and then this sign right here does not change, so that would be your vertex. Vertex is that turning point. Let's label it. Over here we'd have a vertex as well. You're going to have an axis of symmetry. The axis of symmetry is just the line that goes right down through the middle. If you have a parabola that opens up or down, that's going to be a vertical line, and vertical lines have x equals equations, right? On the one over here to the right, if you have a parabola that opens left and right, it's going to have a horizontal axis of symmetry. So this is our, I'm going to just label AOS there, axis of symmetry. And then One of the last things we need to know is the directrix. And the directrix is this line that's outside of the parabola. And I'm going to show you what in the world that line is here in a second. But the directrix will be perpendicular to your axis of symmetry, and it is going to be, so like, this is your focal length. It's the distance from the vertex to the focus. That same distance will be your focal length, will go from your vertex to your directrix. And we'll do a few of these so you'll know what that looks like. And let me label this one. I believe I have a Desmos graph to show you for this to understand like what in the world that directrix is, because it seems like something useless. I used to not teach directrix because I thought directrix, I've never heard of that, you will never need it. And then they started testing it on the exam, so I had to start teaching it. And I've grown to think that it's at least a little important. I had a different one. I may have to go back and look through it. Well, no, that's tangent on this. Okay. I'm not sure where it's at. I'll make sure I have a link somewhere. Oh, here it is. Alright, so a parabola is defined as a set of points equidistant from a point, I should say, and a line. This is really being hateful. Why is it lagging so? Come on. It is stuck. Close it and open it back up, maybe. Oh. Let's try it again. Okay, here we go. Alright. Now let's try and link that. Let's see if it'll copy and paste. Here's what I was looking for. Okay, good. So I did have it. So, a parabola is all of the points that are equidistant from a focus and a directrix, the same distance from a point and a line. So if you look, like the point that we would start from sort of here is the distance from the vertex to the focus is the same as the distance from the vertex to this line right here, which is our directrix. And so that is the case everywhere on this parabola. You can see these two red lines right here, these two dotted red lines, have the same length everywhere. So even if we zoom out some and go like way over here, the parabola has the property that you're the same distance from that focus and the directrix in every case. So that is sort of how a parabola is made there. You could use that sort of for constructing. This could be important if you are creating something that's parabolic in nature for a purpose. So I want to say that they can do like parabolic lenses. Sometimes like things like satellite dishes and stuff might have this shape, and they might have certain properties that they want it to have. So you could work sort of backwards from this. So, also look at all that math right there. That's fun, isn't it? I created all that so it would draw those lines. It's exciting. All right. So, let's look at what it looks like. So for each one of these, we want to find the vertex, focus, directrix, and axis of symmetry. So, for this one, I have an x equals, and my y is the one that is squared. So if my y is squared, which is not squared right here, but it's being squared because of the parentheses. If my y is squared, that means that we're going to open to the left or to the right. So we need to look at this number right here to tell whether or not it is positive or negative. So since this is positive, that tells us that it opens to the right. Okay, so positive is going to be the right direction. So I am just going to sketch a rough draft of it. I'm not going to make you guys graph parabolas, but it will be helpful to sketch a graph of it as you are finding the different points that are being asked for. So, for the vertex, that's what you want to start with. For our vertex, we've got y minus 4. So our y coordinate of our vertex is going to be the opposite sign of that negative 4. So we'll get a positive 4. If you think about shifting things, whenever they're inside of the parentheses, they go the opposite direction. So we're going to have a positive 4, and then this other number over here on the end, 3, that's going to be our x coordinate. Now, if we had the switch where it was y equals, then those would be opposites, right? Because we'd have an x right here. So our vertex is at the point, I'll label this here. This is the point 3, 4. Okay, here. All right, so we also now need to know our focal length, because that is going to help us find our focus and our directrix. So that P, and this is something that I will give you on the board, remind me, I will give this to you. When we used to have state exam, they gave you a formula sheet that included this. So it's 1 over 4A. And A is this number right here out front. So for this particular case, we're going to have 1 over 4 times 2. So 1/8. Or I'm going to go ahead and use a decimal for that, which I believe is 0.125. So, at this point, this is where I really rely on my picture. So if I want to go from my vertex to my focus, in this case, because I know this opens to the right, I need to go to the right 0.125. Okay, that's my length. So if I do that, if I move into the right 0.125, then Maddox, which coordinate is going to change? My x coordinate or my y coordinate? X coordinate, right? And we're going to add to it because we're moving to the right. So my focus is going to be at 3.1254. My directrix is going to be that same distance, but to the left. And so, for my directrix, this is a line, and it is a vertical line. Vertical lines, what do their equations look like? It's x equals a number. So it's going to be x equals, and then our x coordinate here was 3. We had to go to the left 1.25. And so if we go to the left 1.25, we will have to subtract. So if we do 3 minus 0.125, we're going to get 2.875. So that would be the equation of our directrix. And then the last thing it's going to ask us for is the axis of symmetry. And the axis of symmetry for this one, it's going to go right down the middle this way. So axis of symmetry is a horizontal line here, which means it's going to be a y equals line. And it goes through the vertex, so it's just going to have the same y coordinate as your vertex, or your focus, or your direction. So it have a y coordinate. Oh, excuse me. But 4 is our y coordinate, so it's going to be y equals 4. Okay, questions? All right. So let's do one where we actually have to put it in vertex form, because that last one was in vertex form for us. This one is just in standard form. It's just given in ax squared plus bx plus c form. So we're going to have to put it in vertex form. It's going to be a lot like we did with circles and ellipses, where we have to complete the square, but a little bit different. So I'm going to factor out this 2 right here, but I'm only going to take it out of the first 2 terms. So I'm going to do 2x squared minus 4x. I'm going to go ahead and put me a plus blank right here. And this plus 5 is going to stay over here on the side. Now, I have a couple options of the way that I could do this. The way that I was doing it with circles and ellipses is I was putting like a plus blank over here on the other side, which I could still do if I wanted to. So adding something to both sides is a way of keeping that equation balanced. So if you add 5 over here, you add 5 over here. Another way that we could keep an equation balanced is if I add a number right here, I could subtract that same number over here, right? So if I add 5 and subtract 5 from the same side, it actually doesn't change the value of that side either, because I've added and subtracted. So rather than adding to both sides here, it's a little bit easier to work with these if you add and then subtract to the same side for this. So you're going to complete the square just like we were for the other problems. So you'll have x right here. Hallie, what will we have in this parentheses here where we're going to square it? Very good. And what number will go in this blank up here? 8 is going to be the number that we need to subtract over here. Right here we would just have a 4, and then the 2 times the 4 would give us the 8 right here. So we would be adding 4 here, which is really like adding 8 because that 2 would distribute there. So we would subtract 8 over here. And so I could put 5 and minus 8 together, and that's going to be minus 3. All right, questions? All right, so we have a y equals, which means this one's going to open up or down. And this 2 right here is the number that we're going to look at to see if it's going to be opening up or down. If this number is positive, then it opens up. That's our positive direction. We have a smiley face parabola. If it's negative, it would be upside down. So in this case, our parabola is going to open up. Our vertex, we will look in this parentheses right here. With the x, we have a negative 2, so we're going to use the opposite sign. We'll get a positive 2. But then over here, this number right here is where our y comes from. We do not change its sign because it's not inside of the parentheses. So it's going to be 2, negative 3 would be our vertex. So this point right here is going to be 2, negative 3. And so that focal length, again, is that P equals 1 over 4A. It's the same as it was on the last one. We've got a 2 right there for our A. So we'll have 1 over 4 times 2. Give us 1/8, which is 0.125. For our focus, now our focus is always on the inside of the parabola, so we would need to go up 0.125. So, Grace, which coordinate is going to change if we're going from that vertex and we're going up? It's the y. So we need to add 0.125 to this negative 3. So when we do that, we'll get 2, and then we'll get negative 2.875. So we're adding that positive 0.125 to our y coordinate. Our directrix is going to be here, but we're going to go down 0.125. And in this case, we have a horizontal line. So horizontal lines are y equals. Again, think about your y coordinate. You're starting from that vertex and you're going down 0.125. So that's going to be negative 3, and we're going to subtract 0.125, so we'll get negative 3.125. And our last would be our axis of symmetry, which would be this vertical line right here. Vertical lines are going to be y equals, so we use, vertical lines are going to be x equals, so we use the x coordinate of our vertex here, which is 2, so we would get x equals 2. It's really important on these that we got x equals, that's a vertical line, and y equals, that's a horizontal. That will help us when we're doing this because you're kind of just going through it logically and you got to know those two. Okay, questions? All right. Okay, here's another one we're going to put in vertex form. and then find those pieces there. So for this one, we have x equals y squared minus 12y plus 4. There's no number to factor out for our y, so we'll just have y squared minus 12y plus blank plus 4 minus blank. And so when we do this, Noelle, what number will we get down here when we complete the square for our y? Good. We'll have a minus 6 right here. What number will go in this blank up here? 36. And so what number should we subtract? Also 36. Very good. So 4 minus 36 is going to give us a negative 32. So our vertex here is going to be at the y coordinate is going to be 6 because this is here with our y. Our other coordinate is negative 32. And this one is an x equals. You don't have a number here for your a. So what number could you put there for your a? 1. So we could think of this as being a 1. Right here, that's a positive number. So this one's going to open to the right. And you're going to have your vertex here at negative 32, 6. So for that focal length, it's 1 over 4 times a, which in this case is just 1. So that's 1/4, or I just find it a little bit easier to work with if you do decimals. So we got 0.25. So focus is going to be to the right. So Blaine, if we're going to the right, which coordinate is going to change here? The x. And we're going to add 0.25 to that negative 32. It's going to give us negative 31.75. And the 6 will stay the same. For our directrix over here, this time we're going to the left. That is a vertical line. Vertical lines are going to be x equals a number, and this time we need to subtract from our x. So negative 32 minus 0.25 is going to give us negative 32.25. And then last, our axis of symmetry is going to be this horizontal line here, and it passes through the vertex there. So horizontal lines are going to be y equals a number, and the y coordinate there is 6. Morning, Luis. All right, questions? All right, let's look at this one here. All right, so just looking at this one, is this going to be a parabola that opens up, down, left, or right? It's not going to be down. I think it's going to be right. I know it's left or right because I only have just a single x, but I have a y squared. So if you just have an x, that tells me left or right. So let's move this around a little bit. So I would have x equals, I could move that 30 over here. I'm going to put the 3y squared first. That should be minus 30. I'm going to move it over. Or I like for that x to be on the left-hand side, so I'm just going to switch here. And so if I factor out my 3, I've got 3 times y squared minus 3y plus blank minus 30 minus blank. I don't know if you guys ran into these much where you don't get whole numbers here, but process is still the same. Alright, so what number would I have right here in my bottom parentheses here when I complete the square? Negative 1.5, or I'm going to just go fractions and do 3 halves. But you still just take half of this middle number, right? And that's fraction, which is ugly. And then you are going to square that number here. And the reason I'm using fractions is because to square that, I can just do square the top, get 9, square the bottom, you get 4. And then I have to take 9/4 and multiply it by 3 to get the number that I add over here, which is going to give me 27 over 4. Now, at this point, if you want to use decimals, it's fine. It might be a little bit easier as far as telling the Vertex and Directrix here. You will have your calculator on these. You won't have Desmos on everything. There will be some parts that you have Desmos on and some that you do not, because some of the things I do want you to be able to like type it into Desmos to check to see if you're right. I don't want to give it to you on everything because Desmos is too powerful. It can just graph ellipses, you know, just right off the bat without even having to think about it. So, but you will have your calculator. So here, let's see though, that's going to be what do we get there? 6.75. That's right. So we get negative 36.75. If you would rather at this point change this to 1.5, you can. It's just up to you. So because this 3 right here is positive, this one's also going to open to the right. Vertex is going to be at the y coordinate is the opposite of this 0.15, so we'll have positive 0.15. We get negative 36.75 here. So this is our vertex right here at negative 36.75, 1.5. Our focus would be to the right, and we're going to do 1 over 4 times 3. Which is going to give us 1/12, which is going to be, as a decimal, 0.083 repeating. So our focus, we're going to take, we're moving to the right, so it's going to affect our x coordinate. So we take that negative 36.75 and we add 0.083 repeating, and we're going to get negative 36.6 repeating, 1.5. And then our Directrix, it's going to be over here. It's a vertical line, which is the x equals. So we take our negative negative 36.75 and we subtract the 0.083 repeating, and we're going to get negative 36.83 repeating there. And then our last thing is that axis of symmetry, which is horizontal. And since it is horizontal, it's going to be y equals, and our y coordinate is 1.5. All right, questions? All right, let's see. Oh wait, I skipped this one. Okay, I want to do this one. We're actually going to skip that x and y intercept one, but so we got y squared equals negative 4x times x minus 3. This one kind of looks like it's in vertex form, but it's not in vertex form because we need it to be x equals or y equals, not y squared equals, right? So this would be an x equals problem because your x is not squared in this case. So we need to solve this equation for x. So we would distribute that negative 4 first. So y squared would equal negative 4x plus 12. And so we're solving for that x right there. So we're going to have y squared minus 12 equals negative 4x, or we could write it like this, negative 4x equals y squared minus 12. There's nothing to complete the square with here because you don't have a y. You just have your x. I'm sorry, you just have the y squared. So you're actually not going to complete the square here. What you're treating this like is like the square is already complete and like it's a y plus 0 squared minus 12. That's kind of the way we're thinking of this. You definitely don't have to write that, but that helps it look a little bit more like it's vertex form. But this is equal to negative 4x. So we have to divide by negative 4. And so when we divide this by negative 4, it's like we've got a 1 right here in front. And so we're going to divide this by negative 4, and we also have to divide this other term over here by negative 4. So we will end up with x equals negative 1/4 times y plus 0 squared plus 3. And again, that plus 0 there is totally unnecessary and really not even the best practice because you're not going to, like if you have answer choices here, they won't put the plus 0. They'll just have y squared plus 3. But it's going to help us a little bit when we have to do our vertex. Because our vertex, our y coordinate is the opposite of whatever's in there with the y, which in this case actually there is no opposite because it's 0. So your y coordinate is going to be 0. That x coordinate is 3. Connors, this one going to open up, down, left, or right? It's going to open left. This is our first one that we've had left. I've done mostly left and right just because they're different than what you've seen before here. So this vertex here is at 3, 0. So we have to find that focal length. So we'll do 1 over 4 times a. I ignore the signs. There's a way you can do it with the signs, but I use the picture instead of signs. So since that's negative 1/4, you ignore the negative, just do 1/4. 4 times 1/4 is 1, so we just get 1 over 1, which of course is 1. So our focal length here is 1. So our focus is going to be on the left side this time. And we need to go to the left 1. So Jackson, will that change our x coordinate or our y coordinate? the x because we're moving to the left. And since we're going left, we need to subtract. So our focus will be at 2, 0. We'll just subtract 1 from our x coordinate there. Our directrix is going to be over here on the right-hand side. It is also just 1 unit away. So our directrix, it's going to be x equals, and this time we're going to add 1, so we'll get 4. And the last one is our axis of symmetry. It is horizontal, which is a y equals, and the y coordinate there is 0. Okay, questions? All right, we are going to skip the x and y intercepts. I think I just don't really want to do those. So your assignment is going to come from the textbook again tonight, and I have put a picture of that on Canvas so you guys can see it. And, oh, no, wrong thing. All right, and we're going to be doing 13 through 21. It asks you to graph, but you do not have to graph. You can just sketch a rough graph like I'm doing to help you as you're doing these problems. I do want to do one of these together because there's one that is difficult to do. It's not difficult. I just need to show you an easier way of dealing with it. So I'm not going to do the whole thing. I'm just going to start number 16 for you here. And 16, you got y squared plus 12y equals 2y minus 13. And so we want to get the the semi-y's. This should be an x right here. Let me fix that. So should this one be solved for x or solved for y? It needs to be solved for x because x is not squared, right? So that means I would need to move the y squared over. I'll get 12x equals negative y squared plus 2y minus 13, like this. Now here's the problem. On everything else we've done, all I had here was an x, so I didn't have to worry about that 12. If I divide everything by 12 right now to get the x by itself, I'm going to have fractions and bad fractions over here, right? Like 1/12, 1/6, and 13 over 12. So if I do that now, which it can be done that way, I'm going to have a lot of fractions to deal with. The other option is to go ahead and complete your square as it is right now, and then worry about the 12 at the very end. So that's what we want to do. So pretend like that 12's not there, it's just sitting over here. You're not doing anything with it. So you would just need to factor out this negative 1 right here, which would give you y squared minus 2y plus blank. And we'd have minus 13 minus blank right here. And so in this parentheses here, when we're completing that square, Maddox, what number will we get right here? Very good. And then what number goes in the blank on the line before? Positive 1. What number do I have to subtract over here? it's going to be a negative 1. What happens is, like, we do 1 times this negative 1 that's been factored out. So we got minus a negative 1, so it'll be like we're just adding that 1. So we get minus 12 right here. So we put this in almost standard form. And then we're going to divide by 12. And when I divide by 12, I need to divide each term by 12. This whole thing is a term because it's all multiplied together. And this last number over here is a term. So x will equal negative 1/12 y minus 1 squared minus 1. So that would be in standard form for us. And then I'll let you do the other parts of that for your Vertex and Directrix and all of those things. The same thing is going to happen on number 18 and number 20, where you want to just hold on to that number that's in front of your x and divide it off at the end when you're putting it in standard form. Okay, sometimes students also have trouble on 13 there. You got y squared equals 8x. So you're trying to get that x by itself. You would divide both sides by 8. This has like a 1 in front of it. So this would be x equals 1/8 y squared. There's no completing the square to do on this. It is like having x equals 1/8. Sorry, that's an 8. 1/8. And then it's like having y plus 0 squared plus 0. So you can fill in those blank zeros where you don't have anything. So you have vertex at 0, 0. That one gives students trouble sometimes because it doesn't really have to be solved. All right, questions? All right, so go ahead and get to work. You got a little bit to start on those. I'll be around if you guys have questions.